Alright, we will finish up the practice test now. So these are word problems involving rational equations, and I always find it helpful with a lot of these to draw a picture. It's sometimes easier to have a visual. Picture's worth 1,000 words. So it says Leah wants to make a 40% acid solution, and for all of these we're going to use decimals instead of percent. So here's some solution, and she wants to make it so that it's, so we'll set it up a couple ways just to kind of give you the picture. We need amounts of acid in each one, and then kind of concentrations as well. So let's think about the best way to set this up. So first of all, what she's doing is she wants to make a solution. So this is going to be the 40% solution. And the way that she's going to make that is she's going to do this. She's going to pour 4 liters of 60% acid. So 4 liters. Actually, let me write it in here. She's going to have 4 liters of 60% acid, so 0.6 is the 60%. The question is, how many liters of a 30% solution must she add to this? So this is some X stands for the number of liters that we don't know, and we know it's 0.3, it's 30%. How many liters must she add to the 60% one to create the desired mixture? Okay, well, let's think about it this way. If she has 4 liters and she's adding some unknown number of liters, that means her total is going to be 4 plus X liters. Okay, and then here we don't know what the final percent is. Okay, but we do know this. We know that it's going to be. Well, actually, let's do the total acid first, because that will be a little bit easier to focus on. So if we have 4 liters and 60% of it is acid, that's going to be 60%. 0.6 times 4 is 2.4. Okay, the reason we're doing this is just so we can get the total acid concentration over here. And we already know that this one has to be 0.4, by the way. Okay, because they're telling us that she wants to make a 40% solution. Okay, how much acid does she have right here? Well, she has, over here we did 4 times 0.6 to get this number. Here we'll do X times 0.3 to get 0.3X. So that means her total amount of acid is 2.4 plus 0.3X, because that's how much acid is in the other one. Now here's what we need to think about. We know for sure that she's going to have this much acid right here, 2.4 plus 0.3X. That's the total amount of acid. That's going to be equal to what? Well, think about it this way. To get this number, we multiply this times this. To get this number, we multiply this times this. So we can follow the same pattern. If we multiply these together, if we multiply the amount of solution times the percent of it that's acid, we should get how much acid there is. And we already know, based on this stuff, that it's 2.4 plus 0.3x. So let's do 0.4, 40% of this solution is acid. How much solution is there? We don't know. It's 4 liters plus this amount, which we don't know. Okay, now once we have this, it's very easy to solve. It's just a basic linear equation. The hard part of these problems are the setup. So 4 times 0.4 is 1.6, and 0.4 times x is 0.4x. Okay, now we're going to move all the x's to one side, so minus 0.3x from both sides. That's going to leave us with 0.1x. And let's subtract the 1.6 from both sides. It's going to leave us with 0.8. If you divide both of these by 0.1, you would get x equals 8 liters. And you could always check that by plugging it in and seeing if it works. Okay, it will. So if you plugged in 8 right here, you'd have 12 liters at 40%, and that's going to be 4.8. You plug in 8 right here, you'd have 8 liters at 0.3, which is 2.4. We already knew that this is 2.4, so 2.4 plus another 2.4 gives us 4.8. So it should be that she added 8 liters. Okay, here is a bicyclist. If you ever bicycled on a windy day outside, you know that when the wind is in your face, it slows you down a lot, but vice versa, when you turn around, you get the tailwind, it speeds you up. So because we're dealing with distance and time and rate here, the formula that we will want to use is distance equals rate times time, d equals RT. Okay, we are being asked to find the speed, which means to find the rate. So we want to solve this equation for rate, which we can do by dividing by t. So distance over time is equal to rate. Okay. Actually, you know what? I misspoke there. Even though they are asking us to find average speed, it's easier in this case to do this by using the amount of time they gave us. So hopefully this makes sense if you think about it. The total time that it takes him The total time that takes him equals the time that he spent riding. It's a round trip, it says. So the time that he spent going out plus the time that he spent coming in. Total time is the time that he spent riding out plus the time that he spent coming in. So we've got, here's a cyclist, he goes out, he turns around, he comes back. This total time they're telling us is 4 hours. So 4 hours, and again, I know I told you up here something different, but let's correct this for a second. It's easier in this case to solve for time instead, because they're telling us the time. So the other stuff is where we're going to get variables. So we'll divide by r. So that means time is equal to distance over rate. Time is distance over rate. So how much? So we know this right here. We know his total distance is 130 miles, right? So this right here and this right here are going to be the times that he spent going out, the times he spent going in. Okay. His time right here is distance over rate. How much distance did he cover on his way out? Well, if the whole trip was 130 miles, he must have covered half of it on his way out, and half of it is 65 miles. Okay, how much time did he spend going out? Well, his distance was 65. We have to divide it by his rate. His rate is 33 miles an hour, but then they don't tell us whether he was with the wind or against the wind going out, but it doesn't really matter. So let's call x the wind speed. Let's pretend that on the way out he was going with the wind. So the wind was pushing him, the wind was adding to his speed. That means 33 miles an hour plus the wind speed plus x. And I was talking to a physicist about this. This setup might be a little bit technically inaccurate because a bicycle also has other forces like from friction on the road and stuff. If you were taking a plane and the only thing pushing a plane, the plane is kind of in the air, the only thing pushing is the wind. If a plane is going 500 miles an hour and wind is going 10, it's going to go 510. It's not quite the same with a cyclist because the cyclist has the bike touching the road. But the important part of this problem is knowing how to set it up. Obviously, if you're doing physics, you'd fill in the other details. Okay, how much time did he spend coming back in? He turns around. Well, we know he went 65 miles. That's his distance. And we know that now, because he had the wind adding to his speed on the way out, now it's in his face. It's subtracting from his speed. So I hope this makes sense. This right here, this value, is the time that he spent going out. Why is that time? Because time, we set up here, is distance over rate. His distance was 65 miles. His rate is his normal speed, but the wind is pushing him, so his speed plus x. This is time coming in. Why? Because again, time is distance over rate. We know his distance was 130 round trips, so 65 miles. And then his speed, but now because he had the wind with him on the way out, the wind is against him on the way back. Okay, now this problem is actually a little bit easier than what we did before. So we did a whole bunch of these on the other page. We need to multiply everything by the common denominator, which is 33 plus x times 33 minus x, because that will cause things to cancel away. Okay, so again, just like the chemistry example with the acid solution, the hard part right here is setting it up correctly. So 33 plus x times 33 minus x. Okay, if you distribute to this, the minus x's will cancel, so we'll have 65 times 33 plus x. And what's that? 1980 plus 165 is 2045. And then 65 times the x is plus 65x. Okay, then we have a plus. And now if we distribute to the other one, we'll do this in a different color, if we distribute this whole thing over here, the 33 plus x's will cancel, but the 33 minus x gets multiplied by that. And that's going to be 2045. 65 times minus x is minus 65x. So those parts will cancel, and we'll be left with 2045 plus 2045, which is 4090. Okay, what does that equal? That equals whatever the other side's going to distribute to. So we have 4 times this thing. Let me write it a little bit more clearly so you can see it. Okay, we have 4 times this thing. Let's FOIL this out first. 33 times 33 is 1089. Plus 33x minus 33x, the outside and inside terms cancel. And x times negative x is negative x squared. And then we still have that times 4. So if we distribute the 4 times that number is, what is that? 4,356. And then we have minus 4 times x squared is minus 4x squared. Okay, now we're almost ready to begin to solve this. So let's move the numbers to one side, the x's to the other. So that will cancel. If we subtract 4,356 over here, we would get negative 266, I believe. Let's just double check that. 200, yeah, negative 266, and that equals negative 4x squared. We'll divide by negative 4. So x squared equals, this right here reduces to 133 over 2, which also reduces to 66.5. How do we solve for x? We square root both sides. And we'd normally put a plus or minus, but minus doesn't make sense because x is the wind speed. You can't have a negative wind speed. So the square root of 66.5, it should be something around 8 or so. And I think this might be, this I believe is a typo. Yes, the wind speed. Here's how we can check. I think this is an error. Let's check it. So we'll actually find what the square root of 66.5 is. I'll just grab a calculator real quick to do that. Square root of 64 is 8. So the square root of 66.5 should be, it's 8.15. Okay, here's how we can check to see that we did this correctly. So x equals 8.15. All we need to do is just plug that number into this equation right here. And I'm just trying to see how they might have got 30 miles an hour. I don't think that can be right. Here's the problem. We're supposed to divide. That's supposed to just be 4 hours, right? They're doing distance divided by time, which is a rate. So that's not right. So this is definitely a typo. But here's how you can check it. Let's do 65 over 33 minus 8.15 plus, and then same thing right here, 65 over 33 plus 8.15. Remember, both of these are times. This is distance over rate. This is distance over rate. So time out plus time in, and that should be 4 hours of time. So let's just plug that in, and we'll see if we get something that's pretty close to 4. We rounded it. It might be like 3.99 or something. Then we should have done it right. So we'll do 65 divided by 33 plus that number, and then we have to do plus 65 divided by 33 minus that number. And you know what, I made a mistake here in how I entered this, and I'll show you what the problem is. We want to divide 65 by that whole thing. The way that I wrote it right now is we're just dividing it by 33. So I did second insert, and we need another parentheses because the calculator will do exactly what you tell it, and I told it to divide by 33 and then add 8.5, and that's not what we want to do. I want to divide it by that entire number. So when in doubt, use parentheses. Okay, if all goes well, if this is right, we should hopefully get 4 hours approximately, and it's pretty close. The reason it's inaccurate, I think, is because we rounded. Okay, but that's how you would set it up right there. All right, last two. It says it takes Nicole 8 hours to oil the lanes in a bowling alley. Julio can oil the same lanes in 7 hours. If they work together, how long would it take them? So here's the setup. Nicole's time plus, or sorry, I should say Nicole's rate plus Julio's rate, I should say, is going to equal their combined rate. If you combine their respective rates, they're going to finish obviously faster. So we know our final answer should be something faster than 7 hours, because Julio can do it in 7, and if he's getting help, it should be less than 7. So what's her rate? Well, if her rate is, it takes her 8 hours to do the job, so it should make sense that if it takes 8 hours to do the job, that means she does 1/8 of the job every hour. She does one, so we're looking for what portion of the job does she do, because we're trying to add her portion to Julio's portion to get their combined. So she does 1/8 of the job per hour, because it takes her 8 hours. You multiply 1/8 times 8, you get 1, you get 100% of the job. Julio does it in 7 hours, so he does 1/7 of the job per hour. We don't know what their combined rate is, so they do 1/x of the job per hour. Okay, so let's do exactly what we're doing on the other one. So actually, this is a little bit easier. We can make a common denominator of 56 right here, 7 times 8. So this is going to be 7 over 56 plus 8 over 56, which is 15 over 56. And that's equal to this. It's equal to 1 over x. Now all we need to do is cross multiply. Or actually we could just flip that around, but that's going to equal this. It's going to be 15x equals 56. And if we divide by 15, we would get x equals 56 over 15, and that comes out to be 3.6 or 3.7 roughly. I don't have a calculator with me in the moment, but it turns out to be 3.73 hours. So 3 hours and 43 minutes or something like that. Okay, this problem is almost the same, just the setup is slightly different. Working alone, Daniel, so his rate, can pour a driveway in 8 hours. That means he does 1/8 of the job per hour. His friend Matt, so this is Matt's rate, helped him, and it only took 2.6. So they don't notice, they don't tell us what Matt's rate is, so that's what we don't know right here. But we do know that together their combined rate was 2.67, so that means they do 1.267th of the job in that time. Okay, let's solve this for x. Let's subtract 1/8 from both sides. We'll subtract 1/8 from here, and then we get 1 over x. You box that off. 1 over x equals whatever this is. So this common denominator is not that convenient, and because you do have a calculator for this, it would be best to use it. So 1 over x equals whatever this is right here, which we'll find in just a sec. And then notice it's 1 over x. I can just flip that over to get x, which means I'd have to flip this number over. Okay, whatever you do to one side, if you're flipping one side over, you can flip the other side over too. So let's do 1 over that fraction right there, and then whatever the answer is, we'll flip it. Okay, so 1 divided by 2.67, and then we're going to do minus 1/8. Okay, so that's 0.249, so that means 1 over x equals this. 1 over x equals 0.249, and as a fraction, that's 0.249 over 1. So if we flip that over, it should be 1 over that, and that's roughly equal to 4. It should be a little bit more than 4. It's like 4.01. Alright, so that is Chapter 8 practice test on rational expressions and equations and so on, and hopefully it makes a little bit more sense.